Welcome back to The Explainer. Today, we're taking apart a seriously fascinating system. We are going to tear down the architecture of the 905 Wood Digital Refinery. For this teardown, I want you to imagine I'm your lead-edge AI engineer and full-stack mobile architect. We're going to look right under the hood of a system that takes one of the most chaotic environments you can possibly imagine, construction waste, and enforces rigid international compliance using mobile edge computing. It is an absolutely incredible intersection of hardware, software, and real-world logistics. So let's get into it.
Okay, let's dive right in. 9. According to industry trackers, Ontario landfills could be completely full in just 9 years. I mean, we're right on the precipice of a massive capacity crisis here. The province generates some of the highest levels of waste per person globally. And get this, 2/3 of that comes from industrial, commercial, and institutional sources. There simply isn't anywhere left to put it. This forces waste to travel further, crossing municipal and even international borders, which, as you can guess, triggers a whole cascade of regulatory hurdles. And that brings us to the core thesis of today's explainer. 905 Wood calls their system the sentient bridge between chaotic construction waste and the high purity requirements of the biocarbon market. It's really about taking physical chaos, literally dumpsters full of random wood, and turning it into a verified, audit-proof commodity. They aren't just moving trash, right? They are refining data at the source to guarantee absolute purity before a truck even leaves the construction site. Here is our architectural blueprint for today. We'll look at the transboundary waste chaos, architecting the dual-layer stack, the digital refinery application workflow, the edge AI verification gate, and finally, audit-ready outputs and economics.
Section 1. The transboundary waste chaos.
So the regulatory backdrop in Ontario is tightening rapidly. We've got regulations 102/94 and 103/94, which mandate intense waste audits and source separation for large projects. But the real pressure cooker? That's the timeline. There's an impending R-Wood landfill ban coming in 2029 and a total exhaustion of domestic capacity by 2034. Because of this, the province is demanding unprecedented, precise digital compliance. The era of just throwing everything into a truck and hoping it passes inspection? Yeah, that's totally over. The real driver here is the financial exposure. We're looking at the circular levy, which is Ontario's circular economy landfill tax. Look at the spread. Verified clean wood is taxed at just $5 a ton. But if a load is classified as mixed waste, it gets hit with a punishing $60 a ton. That $55 spread is exactly why source-level verification is non-negotiable. If you can prove a load is clean, you save a fortune. If you can't, well, your margins are instantly destroyed. Section 2. Architecting the dual-layer stack. It all starts with our hardware and OS core. We're deploying an industrial application directly onto a commercial smartphone right there at the bin site. Specifically, we're using the Google Pixel 10 Pro. Why? Well, because it houses the Google Tensor G5 chip with a dedicated edge TPU. This lets us run massive AI models natively without any internet latency. It also features the Titan M2 secure element running on Android 16, which is absolutely critical for locking down the cryptographic proof of exactly what the camera sees. To pull this off, we use a dual-layer stack. On the device itself, the Edge AI layer uses LightRT to run the Gemma 4 family of models. This gives us sub-second triage power to visually scan the wood instantly. But for the heavy lifting of regulatory mapping, we lean on the Cloud AI layer. Here, Gemini 4.5 powers Vertex AI pipelines and AlloyDB. The cloud handles what 95 Wood calls explainable compliance, matching every single classification back to specific Ontario Regulation 347 codes. Section 3. Digital Refinery Application Workflow. Because operators are out there wearing thick work gloves in high-glare environments, our UX has to rely on high-contrast tactile feedback across this 5-step buyer journey. It kicks off with the public RFQ intake, capturing the bin size and computing the estimated weight automatically. Then, a decoupled quote is generated, explicitly showing those massive levy savings we talked about. Step 3 is carrier dispatch. Step 4, this is the magic moment, Edge AI bin classification by the driver. And finally, Step 5 generates the audit-ready invoice. We have to design this around a very strict metric, the 2-second rule. When a driver aims their Pixel 10 Pro at a dumpster, they cannot be standing around waiting for a cloud server to buffer. The multimodal intake, that's photo and video, feeds directly into the 2.3 billion parameter Gemma 4 E2B model running natively on the hardware. It renders a provisional classification result in under 2 seconds. Actually, scratch that. The end-to-end inference actually happens in under 500 milliseconds. It's incredibly fast.
Section 4. Edge AI Verification Gate.
Now, how do we handle visual uncertainty? With this escalation ladder. Step 1 is that blazing fast E2B model scanning the load. But what if the AI isn't entirely sure? Let's say it scans some weathered gray pine that might be hiding chemical CCA treatment, and the confidence drops into that 70 to 85% amber band. That automatically triggers step 2, the E4B consensus guard. This is a heavier 4.5 billion parameter model that steps in for a second opinion. If they still disagree, it moves to step 3, escalating to physical X-ray and near-infrared sensors back at the receiving hub. So the crucial point here is defined by this logic gate, the precautionary principle. If the fast E2B model and the heavier E4B model disagree, the system triggers an escalation. A human and an AI consensus miss is required to breach the system. The absolute doctrine here is to always reject on ambiguity, to prevent massive contamination penalties later down the line. Once a load is confidently classified as clean, we trigger what's called the hold-to-seal chain of custody. We use the smartphone's Titan M2 hardware root of trust to seal the record. This locks in the GPS coordinates to within a meter, a secure timestamp, the exact AI model version used, and we wrap the whole shebang in a cryptographic kernel hash. This makes the classification legally defensible against Ontario regulators and U.S. Border Patrol. It's literally an audit-proof vault in your pocket. Section 5. Audit-ready outputs and economics. When we generate the final PDF reports out of the application, we use a very deliberate design language. It's monospace typography. It's black and white, fax-ready, and what they call border officer-friendly. These documents must look authoritative, right? Because they're designed to survive intense scrutiny from U.S. Customs and Border Protection. They are not meant to be pretty. They are meant to be an impenetrable compliance firewall. This system generates a 9-point certificate of origin, essentially acting as a USMCA shield. It classifies the waste under HS code 3825.0 as a wholly obtained good. It prints the entire chain of custody lineage, that hold-to-seal cryptographic hash we just talked about, and it is all QR encoded for instant digital verification by a customs agent. So why go through all this trouble? $1,140. Under the USMCA trade agreement, if a waste carrier attempts to cross the border into Michigan without this valid certificate, they get hit with a severe 40% non-compliance transshipment penalty. For a large mothership trailer, that is an immediate $1,140 surcharge. By generating this document using our AI architecture, 905 Wood delivers an 812% return on investment per load just by avoiding that single penalty. This macroeconomic breakdown highlights the financial engineering module. This is what 905 Wood calls decoupled billing. The client sees exactly what they're paying for. They see that tiny $12.50 clean circle levy, knowing full well they just avoided over $1,000 in mixed waste fees. But notice the bottom line there, the carbon dividend. Because the wood is verified clean, it yields carbon removal credits. The client gets the massive levy savings, but 905 Wood retains 100% of those highly lucrative carbon dividends. It is a brilliant masterclass in separating logistics costs from environmental assets. To summarize our architectural teardown today, we've executed our core thesis perfectly. On one side, we have chaotic, mixed construction waste, which is a massive liability in a world quickly running out of landfill space. On the other side, by operationalizing a state-of-the-art edge AI stack right on a commercial smartphone, we output verified purity and explainable compliance. We have literally turned garbage into a globally traded audit-proof asset. Which leaves us with this final, provocative thought to ponder. If a commercial smartphone can successfully enforce international trade law and complex environmental regulations from the side of a muddy construction dumpster, what other massive regulatory moats can edge AI completely dismantle next? The decentralized future of compliance is incredibly exciting. Thank you for joining me on this explainer. Keep building and stay curious.